All right. Well, if you're doing this on Thursday, happy Thursday. And it would really be a happy Thursday because you're doing two note sets in one day, which would be super fun. Or if you're doing this on Friday, obviously it's a happy Friday. The next type of factoring that we're looking at would be difference of two squares. Okay, so sometimes you'll hear that as DOS or dots. So difference of two squares or difference of squares. So basically what that is if it's you have a difference, which means that you're going to have a subtraction problem. So it has to be subtraction. Okay, and then of two squares. So both of these terms have to be perfect squares. And what you can do with that is then take the square root of both of them and separate them into two sets of parentheses here. Okay, so for this first one, x squared minus 25. So it's subtraction, so it's difference. And then x squared we know is a perfect square, and 25 is also a perfect square. So if we factor this, okay, so we're saying what times what gives us x squared, which would be x times x. And then it's always going to be subtraction and then addition. Or it could be addition and subtraction. Either way is the same. And then the square root of 25 would be 5. Okay, so just like when we learned about foiling conjugates, right? We learned that the middle terms canceled out and you would get x squared. And again, it would be plus 5x minus 5x, which would cancel out, and then minus 25. Okay, so this would be how we factor the difference of two squares. So number 2 here, we have x squared minus 4. Okay, so again, x squared is a perfect square, x squared is a perfect square, and 4 is a perfect square. So we would separate this into our two sets of parentheses. X times x gives us the x squared, and we would make subtraction and addition, and then 2 times 2 gives us 4. Okay, so x minus 2, x plus 2. And again, we can check this by foiling it. So we would do x times x is x squared plus 2x minus 2x and then minus 4. Okay, so the middle terms again cancel out because those are conjugates. All right, so for number 3, we again, x to the fourth would be a perfect square, right? X to the second times x to the second, and 16 is also a perfect square. So we're going to make our two sets of parentheses. So we know x squared times x squared gives us x to the fourth, and we know that 4 times 4 gives us the 16. All right, so this is a super fun one, people. Get excited. We are not finished yet, okay? So think to yourself for a minute what else you could do here. All right, so x squared plus 4. This is addition, right? So we cannot do anything with that. That's not a difference of two squares. But x squared minus 4, that's subtraction. And x squared is a perfect square, and 4 is still a perfect square. So we can actually do a double dots here. Okay, so this is going to separate into x times x gives us x squared, and then 2 times 2, right, gives us 4. Okay, so x minus 2, x plus 2. And then our x squared plus 4, that just continues to come down into our answer. Again, we cannot do dots to x squared plus 4 because it's not difference, right? It's an addition problem. Wasn't that fun? All right. So moving on here to number 4. Okay, again, 49x squared is a perfect square, 64 is a perfect square. So I'm going to make my two sets of parentheses here. I know that 7x times 7x gives me 49x squared, and I know that 8 times 8 gives me 64. Okay, so if I were to check this, I would FOIL it. So 7x times 7x is 49x squared. The middle two terms would cancel out, and then it would give me minus 64. All right, so for number 5, again, 9x squared is a perfect square, and 1 is also a perfect square. So I would make my two sets of parentheses here. 3x times 3x gives me 9x squared. And then 1 times 1 would give me 1. Okay, so if I were to check this, I would get 9x squared. My middle terms, again, would cancel out since they're conjugates, and then minus 1. Okay, so for number 6, when you first look at this, 50 is not a perfect square, 72 is not a perfect square, but we can actually do something first for this one. Okay, so you always want to actually look for GCF first. Okay, so first you want to do GCF if there is one. And in this case, there is a GCF here of 2. So we're going to take out the GCF first, and then we're going to have 25x squared minus 36 left over. And now that makes it a difference of 2 squares, right? So 25x squared is a perfect square, 36 is a perfect square. So I'm going to bring my 2 down so I don't forget about it. And then 5x times 5x gives me 25x squared. And 6 times 6 gives me 36. Okay, so make sure that GCF of 2 is included there in your answer. Okay, so this one says, can we factor x squared plus 36? So take a minute here and think to yourself, can you factor that? Okay, and hopefully you thought to yourself, no, because this is addition. Okay, so it is not the difference of 2 squares. Okay, so if we try to get that, right, it would not give us an addition sign. It would give us x squared minus 36. Okay, so we cannot do that if it's addition, so just be careful of that. All right, so that is difference of 2 squares. We're also going to look at factoring by grouping. Okay, so now we have, this is our third method. So we did GCF first, difference of 2 squares, and then grouping. So this basically just keeps getting more and more fun. It's very exciting. Okay, so the first thing that we want to do, grouping, is if we have 4 terms. And we're first going to group our terms. Okay, so we're going to group the first 2 sets of terms and the last 2 sets together. And the next thing we're going to do is we're now going to look at for the GCF in that first set and then the second set. So we're going to look for the GCF here, which would be x squared, which means we would have x plus 1 left over. Okay, and then we would factor out a minus 4 here. So again, this is where it comes into, we want that first term to be positive. So now we have x plus 1 left over. And what's going to happen is you're going to have the same set of factors inside your parentheses. If you don't, you want to maybe play with your sign here to see if you can factor out like a positive 4 to make this the same thing. So you're going to rewrite that term just one time. So we're going to rewrite this x plus 1 just once. Okay, and then you're also going to have the terms that you factored out here. So we had our x squared and our minus 4. Make sure you always take the sign with it. And that's going to be your second set of parentheses. So x squared minus 4. It doesn't matter. We could have written that first or we could have written it afterwards. So this one is a super fun problem because we're still not done, right? So we also have a difference of 2 squares here. So again, this is finished, so it's just going to come down. And then we have our 2 sets of parentheses here. X times x gives us x squared. And we want to do minus 2 and plus 2 to get our negative 4. Okay, so this would be factoring by grouping, but notice we still use GCF. We also still use dots. So you always want to look for everything when you're factoring, which is what makes it really fun. All right, so for this next one, okay, we have 4 terms. So we know as soon as we see 4 terms that we want to group it. Okay, so then we're going to take the GCF out of that first term, which would be x squared. And we're going to have an x minus 1 left over. And then the second term, we're going to take out a negative 9. get x minus 1 left over. And again, if you didn't take out a negative 9, you would then have a negative x plus 1 left over. So you would want to go back and make sure you took out that negative 9 so that you could make the numbers inside the parentheses the same there. So just like the last time, it has to be that the numbers inside the parentheses are the same. So you're going to write that just once. And then you're going to use the values outside here as your second set of parentheses. Okay, so think about if you're finished yet for this one and you are not finished. Okay, so x squared minus 9 would be difference of two squares. So the x minus 1 just comes down because we can't do anything with that. And then we're going to do difference of two squares here. So x gives us x squared, and then a negative 3 and a positive 3 would give us that minus 9. All right, so moving on here to number 2. So for this one, again, we're going to group the first two terms together and the last two terms together. So as soon as you see it has 4 terms there, you're going to do that. And in the first two terms, we're going to take out a GCF of 3x squared, which means we have x minus 5 left over. And the second two terms, we're going to take out a positive 4, which means, again, we have x minus 5 left over. Okay, so same thing happens here. We should have the same thing in the parentheses. So x minus 5 is going to be included once in our answer. And then we're going to get the other part from what we took out. So 3x squared plus 4. This one isn't quite as fun because we can't do any dots. Okay, so that would be our final answer. All right, so going on to number 3 here. Again, we're going to take these and group them. The first set, we're going to take out an x cubed, and then we're going to have x plus 2 left over. Here, we don't have a GCF except for 1, so you are going to take out that 1. So you're going to do plus 1, and that would just still leave you with the x plus 2. Okay, but you do need to make sure to take that out so that when we write down our answer here, we have the x cubed plus 1. You don't just want that x cubed by itself, and then you have the x plus 2. And it doesn't matter what order you write this in, okay, so the factors could be in different orders, that's fine. All right, so go ahead and maybe pause the video and try number 4 here on your own, and then you can play it again to see how you did. Okay, so if you paused and you're checking back in now, you hopefully should have taken out a 5x squared here to get x minus 8, and then taken out a negative 1 to get x minus 8. So you would have gotten 5x squared minus 1 and an x minus 8 for your answer. Okay, and you can do the same thing with the next two problems to kind of see how you're doing on your own. So if you would like to pause the video and try number 5 and number 6, and then check back in to see how you're doing, go ahead and do that. Okay, so if you're checking back in, and you should have taken an x to the 4th out, and so you have x plus 1 left over. You should have taken a negative 16 out, so you have x plus 1 left over. So we have x plus 1, we just write that once. And then we have x to the 4th minus 16. So the fun continues, and we do dots here. So hopefully you guys all did dots. So we bring down our x plus 1. X squared gives us 4th, and minus 4 plus 4 gives us the negative 16. Okay, so it keeps getting more and more fun. X squared minus 4 is still dots. Okay, so we can do that more. So I'm going to bring everything down here that I can't factor anymore. So x plus 1 comes down. The x squared plus 4 I cannot factor because it's addition. And then the x squared minus 4 would be difference of two squares, which makes it x minus 2 and x plus 2.